We'll use burets in the lab a lot to dispense variable amounts of volume, say in a titration. Burets are calibrated in an unusual manner in the fact that they calibrate to 0 when they're full, and they calibrate to the volume of the buret when they're essentially empty, or at least at the bottom of the scale. So this is a 50 ml buret. The liquid is dispensed using a valve called a stopcock, and we have to worry a little bit about air gaps down here, so when we actually run a buret, it's easy to get a little bit of air down here. And this will obviously cause a problem, so we need to avoid it. The easiest way to avoid it is to open the stopcock full blast. Typically the force of the liquid will move through and will blow out this air bubble until this completely fills with liquid, at which point here we've got a buret that's good to go. The volume dispensed or delivered by a buret is calculated by taking the final volume, which is always a large number, minus an initial volume, which is always a smaller number or smaller value. These are called titers typically, so if you had an initial titer of say 1.38 milliliters and a final titer of say 13.88, the volume delivered then would be the difference between those two, which would be 12.50 milliliters. And recall the rules of decimal places, so this is good to 1/100 of a mil, 2 decimal places, so is this one here. And so when we subtract, the delivered volume is also good to 2 decimal places. When we read the buret, we always want to make sure you read it to 1/10 of division. And on a 50 ml buret, the division markers are 0.1 milliliter apart. So you can see here's the 11 line, here's the 10.9, 10.8, 10.7, and so on. So each markings here represents 0.1 of a milliliter. You just have to read it to 1/10 of a division. The meniscus itself is curved, so we always read from the bottom of the meniscus. And so this one right here, if we were to try and read this, the 9.6 line is here, the 9.7 line is here. This is, say, 7/10 of the way down, so we might read this as 9.6 and 7/10 of the division, so 9.67 milliliters here. When we purchase glassware from a manufacturer, it's actually purchased according to a grade or a tolerance. Glassware typically comes in 2 different grades, grade A and grade B. Grade A is the highest tolerance. Grade B has a tolerance that's twice as poor, if you like. And sometimes there's even a grade called student grade, which basically means it fails grade A and B, so we just sell it for pennies on a dollar. It's good for learning how to do titrations with if you want to buy a buret for, 1/10 of the price of a real buret. So here's some values for a grade A buret. So a 50 ml buret has a graduation mark of 0.1 milliliter, as we saw before, and its tolerance is plus or minus 0.05 milliliters. So what that means is that when it's calibrated, it's not allowed to deviate by more than 0.05 of a milliliter from those calibration marks to be grade A. If it was grade B, it could deviate by 0.1, so essentially those marks could be actually 1 off. And if it was student grade, then essentially it's going to be greater than plus or minus 0.1, so you really have no idea what you're getting at all.